Welcome, ladies and gentlemen. So what I like to do is show you how to complete the truth table for a given statement. Now, when completing the truth table, what we basically worked on was conditional statements, inverse, contrapositive, and converse statements. Well, now we're going to be dealing with some statements that, related. We're still doing conditional statements, negation, but they're not going to be your inverse, converse, contrapositive, and converse. So the best thing to do when you want to complete the truth table is start from the beginning. Start with your P, your Q, and if you need the opposite of P or the opposite or the negation of P and negation of Q, then write them down there as well. So I'm not going to do that for all of them because I don't want this video to take too long, but I will do it for the first example so you can see exactly what I would do. So first of all is we need to look at, if we're having a conditional statement, then we know we're going to start with our P. Actually, let's go a little bit bigger here. OK. And let's go ahead and list out all of the different ways for our statement for our P, and our Q that we could have. So in this case, you remember we could have true, true. We could also do a true, false. Then we could do a false, true. And we could do a false, false. Now again, if we were just looking for if P then Q, that would be your conditional statement. But you can see here, they're looking for what if it says if not P, then Q. So we need to figure out what is the negation of P. So I'll just create a new formula here for opposite of P. So that's just going to be the opposite of all these. So that's going to be true. Opposite of true is false, false, true, true. Now, I'm actually going to create a little bit of space here. I'm not needing the yeah, that's fine. Let's just finish it up there. So now let's go ahead and do what if it then is opposite of P, then Q. So remember that the statement is only false. A conditional statement is only going to be false if it's if true, then false. So what I want to do is I want to look at when was my opposite of P true? Well, it's in between these two. Well, then when is my conclusion Q going to be false? And you can see here my conclusion Q is false. So it's going to true to false. If not P, then Q. If not P, then Q. So once I found my true to false, I know that's false. And remember conditional statements. The only time it's false is when you go from a true hypothesis to a false conclusion. So all the other statements are true. OK? So that makes your life a lot easier to find that false first. In this next one, again, I'm going to list my P's. And now here I want to find opposite of Q's. So 1, 2, OK. So my P, I'll do true, true, false, false. Now the opposite of Q, I'm going to take the Q's from here and just do the opposite. So it's going to be false, true, false, true. So therefore, if P, then not Q, is again, I'm only looking for where is it going from true to false. And you can see that happens right in the first one. False or true, so that means that's false. Then the rest of them are true. The next one is going to be the negation of if P, then Q. Now this one's important because what we're going to want to do is follow the order of operations here. So what I'm going to want to do in this one is first thing I'm going to want to do is just do if P, then Q. Because then I'm going to take the opposite of if P, then Q. So the first thing is if P, then Q. So let's kind of go back over here and say, all right, if P, then Q, when is that going to be false? If true, then false. You can see it's that second one, right? So true, false, true, true. OK? Then the opposite of P, then Q is just, I'm just going to take the negation of all these. False, true, false, false. OK? And there you go. Now, the next one, now we're going to get into some conjunction statements. Now, if you remember from set theory, this little symbol here is going to mean and. It is going to mean both. That means the only way that our statement is going to be true is when both of our statements are true. That's it. Both of the statements, the hypotenuse and the conclusion, both have to be true. So this one can be kind of rather simply if P, then Q. Because if I look at this, the only time that both my statements are true is the first one, where it's true, true. Everything else has at least one false. Here it has two false. I don't have any truth in there. So therefore, only the first one's true, and then the rest are false. Notice this is not a conditional statement. This is a conjunction statement. It's either and or both. And basically it's saying that the statement is true when both of the statements are true. Whereas the difference is the or is basically saying their statement is going to be true when one or the other statement is going to be true. Meaning the conclusion or the hypothesis is true, then the statement is going to be true. So all we need to do to determine for a union, this is called a union, this would be like an intersection. For the union to be true is just one of the statements to be true. So if we look at P union Q, that's true. That has a truth, so that's true. That has a truth, so that's true. Here has no truth, so therefore it's false. So P union Q, P union Q, 1, 2, that's true, 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 false. Okay? And then in the same respect, we can kind of work with this. Now what we're looking at is opposite of P and Q, right? But again, we're looking for the intersection. So it only works when they are both going to be true. So let's see, when is opposite of P intersect with Q? So we have opposite of P and Q. So when are they both true? And you can see right here they're both true. So it's going to be false, false, true, false. Union is going to be when is opposite of P and opposite of Q both going to be there. Now, I don't have a table where they're both there. So it might be helpful to kind of redraw our truth statement again one more time. And let's do opposite of P, opposite of Q, and then opposite of P union opposite of Q. And I'm only doing this for visual effect. Obviously, I could probably take the answers back in from here. But I just want to, it's always good when you're doing these to create your truth table. And hopefully, more likely than not, on a test or on homework, you're only doing like 1 or 2 of these anyway. So it's not that much work to recreate the truth table. I'm obviously doing a lot of examples, so I don't want it to take too long. False, true, false, true. That's why I'm skipping some steps a little bit. So again, remember this is union, so therefore I only need one truth for the statement to be true. Well, here I have nothing, so there's false. But here I have a true, and a true. So true, true, true. OK, now the last one is when you have a negation outside of the parentheses of a conjunction statement. This is very important. What you're going to want to do in here, unlike in this one, in here this is a conditional statement. So you find the conditional statement first, and then you negate it. Whereas here, what we're going to do is we can distribute. You could follow the same order of operations. Or what we could do is distribute if P. You could distribute this P intersect opposite of Q. And so now what we're going to do is say the same thing, but we see when do these two intersect. So opposite of P intersect opposite of Q. And you can see that I created these, or I created the opposite of P and the Q over here. So you could say when do they both intersect to be true? And that's going to be only, or sorry, the opposite of P and opposite Q is only going to be true, is right there. So that's true, and that's false, false, and that's false. And then if you're doing the same thing, if you're going to follow the order of operations, basically what you do is take P union Q, which is inside there, which is right here. And then if you're just to negate all of this, it'd be false, 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 true, which is the same thing I got over there. But I just want to make sure you could do this one in kind of either way. So there you go, ladies and gentlemen. That is how you determine the truth statement, truth table, sorry, for your statement. Thanks.